We are talking about the reciprocal functions. So you know reciprocal function, just briefly talk about that. If you have x-intercept, which means y equals to 0 in x-intercept, therefore the x-intercept will become asymptotes, like vertical asymptotes. Same reason, denominator cannot be 0. If you have y-intercept at y equals to b, you still have y-intercept, but at 1 over b, because it's the reciprocal, it's 1 over the y value. If you have maximum turning point, okay, the thing is, the nature will change from original function to the reciprocal function. If you have maximum turning point, that will become minimum turning point at a comma 1 over b. If you have minimum, that will become maximum. Okay, but the y value will all becomes 1 over. If it's stationary point of inflection, it's still stationary point of inflection. Okay, if you have vertical asymptotes on your original one, you will have x-intercept. Okay, x-intercept becomes asymptotes, but asymptotes becomes x-intercept. Okay, so from reciprocal to fx. Horizontal asymptotes at y equals to b, you will have b equals to y equals 1 over b for horizontal asymptotes. And if you have horizontal asymptotes at y equals to 0, you will have y approaching to infinity. But if you have y value approaching to infinity already, you will have horizontal asymptotes at y equals to 0. Okay, so it's all the in pairs. Okay, it's in pairs. Not talk about theory too much. I just say wants to sketch a reciprocal function. How we can say it's a reciprocal function? Boys? We want to say something divided by this quadratic, but I don't really like the minus 3. Well, if you can sketch with the minus 3, I don't really mind, but the way I prefer is to put the minus 3 on the denominator and sketch it together with these values, like that. Yeah, so I factorize the quadratic directly. I put the minus 1 over 3 on the denominator. So all I need to think about is 1 over the y value, 1 over the y value. So denominator is a quadratic. Okay, denominator is a quadratic. There's two types of quadratic can find inverse. Okay, I'll show you both situations. So what's the x-intercept? If that just, I'll use like a blue color to sketch the bottom function. So what's the x-intercept on the denominator? -1, 5. And what is the turning point? Like x equals to 5 and x equals to -1. If you average that, that equals to 2. So -1, 2 minus 5, and 2 plus 1. What that equals to? That's 3, right? 3, -3 times -3 is 1, and 2 plus 1 is 3. So I have 2 comma 3, which is here. And it's a like downward graph. That's the shape. Why does it look so bad? Where's the y-intercept? Where's the y-intercept of this quadratic? So you put x equals to 0, and that's -5, and that's 1. So it's 5 over 3. So that's here. Yeah, the bottom, like the denominator function. All right, this is the denominator, like this is the function on the denominator. And now I also think about the reciprocal one. So obviously this -1 will becomes the asymptotes, because x-intercept will becomes asymptotes. denominator can't be 0. Okay, and 5 will become the asymptotes. What's the other asymptotes we must have? Y equals to 0, because your y is approaching to infinity in both ends, and then 1 over infinity will be 0. So like it's approaching to 0. So you will definitely have horizontal asymptotes as well. Okay, so we have horizontal asymptotes here. So red graph is the graph actually needs to sketch. So x equals to -1, x equals to 5, and y equals to 0. That's the 3 asymptotes. Okay, just as I said, the maximum turning point, this is a maximum turning point, will become the minimum turning point. The coordinates here is 2, 3. So what's the, if I put it becomes the minimum, what's the coordinates must be? 2 and 1/3, so which is here. And that becomes minimum. Okay, that becomes minimum. And what's the y-intercept must be? 3 on 5. Okay, 3 on 5. So 0.6. So it's approximately here. So the graph is like that. It's okay. And how about the other two sides? So for this part is decreasing function. So it will become increasing function like that. And this part is increasing, so it becomes decreasing. And also because the asymptotes is there, you need to get the graph approaching to asymptotes. So the red one will be looks like. The suggestion is you use pencil to sketch the quadratic and clear that. Okay, so you need to get rid of the quadratic. You can't just leave it there. Because I don't know which part is the answer if you keep it. Or otherwise you make it very clear. Yeah, this color is the answer and this is the quadratic. I'm sketching this, showing this one. So you can just get rid of that if you're using pencil. So that's this function. Do you have any questions for that? Label that, that's 0.3/5. Okay, 3 asymptotes, 1 turning point, 1 y-intercept. Okay, that's a revision for the reciprocal. And let's think about that one. I have 2 more graphs. Okay, I want 2 more. This one, sketch the graph of this function. What do you think this +1 would do? Shift up, right? Up for 1 unit. So let's have a think. I will make this function look like fx equals to 1 over -1/5 x minus 2 squared plus 1. And then plus 1 outside. And this is 1 over -1/5 x minus 2 squared -1/5 and plus 1. So my question is, where's the turning point? Turning point. That like we ignore this one first. Okay, don't worry about this one. So what's the turning point here? 2 and -1/5. Okay, 2 comma -1/5. What's the y-intercept? On the denominator, what's the y-intercept? It's -1. Okay, if you sub 0 into that, so it's -1 of 5, 0 minus 2 squared plus 1. So that's -1 of 5 times 5, and that is -1. So y-intercept is -1. And again, it's a decreasing function. But I don't really care the shape, but like, you know, like that's a quadratic. What's the difference between this quadratic and the previous quadratic we sketched? No x-intercept and there's translations. Okay, no x-intercept. If there's no x-intercept, what that means? There's no what? No vertical asymptotes. And what's your horizontal asymptotes must be? Where's your horizontal asymptotes? Originally, if without the +1, where's your horizontal asymptotes? No, without the +1, 0. And then you +1, so you're moving the graph 1 unit up. So your asymptotes is actually at 1. Use another color. Okay, y equals to 1. And where is your turning point now? Like it's a maximum turning point. It becomes a minimum turning point. So where is your turning point? 2, -5 is original one, and then you +1. -5 is original, +1. -4. Yeah, 2, -4 will be the new turning point, but it's a minimum turning point. And where is your y-intercept? Doesn't change originally, and we +1, 0, 0. And by symmetrical property, where's the next one must be? 4, 0. Well, that's pretty much the shape of the graph. You know how to sketch it now? Oh. Well, can't really sketch it, but like the thing is, this is a continuous graph from -infinity to +infinity. There's no vertical asymptotes. Okay, so you won't cut the Cartesian plane into 3 pieces. So you only have one graph below the y asymptotes at y equals to 1. Okay, so maximum turning point becomes a minimum turning point. Asymptotes originally at 0 and it's shift up by 1 unit, so it's y equals to 1. So all the points will shift up by 1 unit. So that's how you sketch it. Do you have any questions? For example, how we get this graph, why we do that? Okay, I'll do a last graph. Okay, so last one. So this is the reciprocal. Okay, that's the two different shape of reciprocal. 5 more minutes, everyone. This is the reciprocal. Like you can see, both of them are reciprocal of quadratic, but you have two different type of graphs. Okay, so two different graphs. I'll do a last one. I'll skip this further graph. It takes a really long time to do it. I'll talk about that tomorrow. I'll do the last page. I'll do this one. Okay, this one think about the behavior when x approaching to infinity, because this is not really rational graphs. We have the square root there, so it's not really a rational graph. It's just some graph we're not familiar with. Okay, let's think about that. What you can definitely say, X has to be greater than 2. Okay, good. What else? X has to be greater than 2. That's my domain. I got the domain. Asymptotes. Do you have asymptotes? X equals to 2. So we have asymptotes at X equals to 2. Okay, what else you can find? Do we have x-intercept? Do you have x-intercept? No, we can't. We can't solve like that equals to 0. We must have x equals to 0, but it's out of our domain. So there's no x-intercept. Again, no x-intercept or y-intercept because x can't equals to 0 either. So no x, y-intercept. What else? So what we can find next? Turning point. So how we can find derivative? Okay, let's go for quotient. So the denominator is just x minus 2. Okay, square the denominator, and then we have square root x minus 2 here times 1 because derive x is 1 minus x times. So we try to differentiate square root x minus 2. So it's x minus 2 to the power of a half. So it's 1 on 2 times 1 over square root x minus 2 minus 1. So it's negative a half. Negative a half is 1 on square root. Okay, so just make it look a little bit better. I don't want to simplify it. I'll tell you why I don't want to simplify it. You can simplify it, or like I can just directly solve. So what do I need is f dash x equals to 0. Because I just want to solve the derivative equals to 0. So I need the numerator to be 0. It's a fraction. I don't care about my denominator. Just make numerator equals to 0. So we have square root x minus 2 minus equals to x over 2 square root x minus 2. That's 2x minus 2 equals to x equals to 4. Do you have x equals to 4? Yeah. Okay. And what's f4? It's 4 over square root 4 minus 2, is it? And that's 4 over square root 2. And that's 2 root 2. So yes, 2.8, not up to 3, so about 3, so 4 and approximately 3, which is here. Well, let's think about the nature. Will we have maximum turning point or minimum turning point here? Can we have maximum? If it's a maximum, what it looks like? What's the problem? You don't have x-intercept, okay? So you must have the minimum. Well, on this side is fine. I can go approaching to asymptotes, but you have x-intercept if you draw like that. So it must be minimum turning point. It must be minimum turning point. Like most of the time, you don't need to test about the nature. You can see what it must be. All right. Now the last thing we need to think about is when x approaching to infinity. Okay, for this one, I don't have another asymptotes. I don't know where the graph like will say this side is must be like that. How about this side? Do we go like that? Or do we go like that? Or do we go like that? Like you need to find something to control the behavior of the right hand side. So let's think about when x approaching to infinity. Okay, when x get really large, what do you think square root x minus 2 approaching to? I'll say that's approaching to square root x, because whether you subtract the 2 or not, it will be the same. Like think about really large number, and you take the square root of the really large number. Whether you minus 2 or you don't minus the 2, it will be the same. Yeah, like you minus the value will be really, really similar to square root x. And so what we have is x minus that is approaching to x over square root x, and is approaching to square root x. X divided by square root x is square root x. So what I have done, is square root x minus 2 will be no difference as square root x when x is really large. Like think about 10 million, square root of 10 million and square root 10 million minus 2. Do you think the value is really similar? Yeah, it's about the same. So the denominator, when x is really large, the denominator will be the same, like as square root x. Then x over square root. Why I'm doing that? Because I want to simplify it. X over square root x gives you square root x. So in the end, to infinity, square root x will be my other asymptotes. It's another asymptote here. So y equals to square root x is my asymptote. Zero, say 1, 1, 4, 2. Well, when is smaller values, it won't be your asymptote, because x and square root x and square root minus x is a huge difference when x is small. But when x is big, there's no difference anymore. So okay, so that's your y equals to square root x. So your behavior in the end will approach into this line. Okay, will approach to this one. So now I can sketch the graph because it get bound two sides. So okay, something like that. It's just approaching to that. It's like it's a square root x. The shape will look like square root x in the end. But when x is small, you won't have this asymptotes. It's only when x is big you have this asymptotes, because it's only true when x is really big. When x is 10, square root 8 and square root 10 still a big difference. But when x is like 10,000, there's no difference anymore. So that's how we sketch this graph. Okay, that's how we find the other non-vertical asymptotes. Think about domain, think about the vertical asymptotes, think about the turning point, stationary points, and think about the behavior. Okay, if you don't have any questions, you can try page 9, okay, by yourself. Okay, spend some time today on page 9, see what you can get, okay, trying to work out turning point, trying to work out anything you can get, and it will approximately takes me 20 minutes to go through one graph tomorrow. It's a really hard one. So spend some time now to work on it, and this one will be the last exercise I'll talk about. So after tomorrow, we'll finish this topic. No, you need to, like, basically they simplify this whole equation. So what this whole equation becomes when x approaches to infinity? It won't be x minus 2. So x minus 2 itself won't be asymptotes. So it's x divided by x minus 2 is the asymptotes. Okay.